Okay, second question. Marine biologist Rita Wales and analyzed 172 dolphins and found 32% of them have elevated mercury levels. We're supposed to find a 99% margin of error and 99% confidence interval for the proportion of dolphins with elevated mercury. We didn't talk much about margin of error. Mainly we did confidence interval. So I'm going to find the confidence interval first, and then we're going to worry about the margin of error. Now, in order to do this with Minitab, Minitab wants to know in our sample how many there were in the sample. So that was 172. And then how many events were there? So how many had elevated mercury level? We aren't told the number of dolphins that have elevated mercury level. We're told the percent of dolphins that have elevated mercury level. So the first thing we need to do is convert that 32% to a number of dolphins. So 32% of 172, that is 0.32 times 172. And that comes out to about 55. Here, let me make that all bigger. I don't know how small that is. That's going to be on the YouTube screen. 55 dolphins. Okay. So there isn't really a good place to plug that 32% into Minitab. It wants to know the number of hits. And so we have to sort of reverse engineer that from the 32% we're given in the information. All right, let's flip over to Minitab. Finish this off. So the confidence intervals were under stat, basic statistics, one proportion. The default here is that it starts on this one or more samples thing. We need to flip that over to summarized data. And we are estimating the number of events at 55, and that is out of 172. So 32% of 172 is actually like 55.04. Oh, that 32 must have been rounded off because 55 is the number that comes closest to giving 32%. So if it was 32%, it presumably came from 55. This perform a hypothesis test does not need to be checked because we're not doing a hypothesis test this time. We're just doing a confidence interval. But we do need to go into the options because we need a 99% confidence level. So we'll change this to 99. And for confidence intervals, you need to make sure that the alternative hypothesis is set to not equals so that if it has a direction inequality, it's going to do a weird one-sided confidence interval. And we've always done confidence intervals that have a top and a bottom, not just like one side and then off to infinity on the other side. Now, in my videos, I've been using the exact method because normal approximation is an approximation and exact is just closer. The practice exam that I posted on the web, the answers that were attached to it, I've been using this practice exam for years and years and years in my stats class. And in my other stats classes, my gen ed stat classes, we have a calculator that doesn't do the exact method. It only does the normal approximation. So the answers on there go with normal approximation. The ones that you get from exact are a little bit different. And I actually prefer the exact ones, and I just didn't think to change the answers on the practice test. So if you use normal approximation, I'm not going to grade it wrong, but if you have to choose, pick exact if you remember to choose. So 99%, make sure there's a not equals here, and the preference is for exact. It's just a better answer. So we'll hit OK, and this is our 99% confidence interval from 0.2314, if we round it to 4 decimal places, up to 0.4184. Okay, so that's the 99% confidence interval. What about the margin of error? So what the margin of error is here's the proportion from our sample, 0.3198, about 32%, right? It was 32% in our sample. The margin of error is how far away from that number the confidence interval goes. So this number should be dead center in the middle of the confidence interval. So there's some amount that you have to go up and down to get to the top and bottom of this confidence interval. That number is the margin of error. So we could just find it out by doing a subtraction. Like if 32% or 3198, I guess, is what it ended up coming out to when we rounded off to 55. If that's in the middle, well, how far is the middle from the top? You just have to take 4184 and subtract 3198. So if our margin of error, if we take 0.4184, which is the top end of our confidence interval, and subtract 0.3198, which was the middle of the confidence interval, the actual approximation we got from our sample, when we do that subtraction, we end up with 0.0986. 0.0986. So that's our margin of error. Now again, that's a slightly different answer than if you use the normal approximation. I think it comes out to, what did I say the answer was here? 9918 if you use the normal approximation. So is that what I got doing this one? Or 916. The 918 was if I did it by hand, I think, instead of using a computer. So something like 918, 916 if you use the normal approximation. So slightly different answer, closer to 9% instead of closer to 10%. Now there is another way to do this, and if you look in the book as to how to find margin of error, it'll go through this other method. So another way to find the margin of error. So another way to find the margin of error is to first find the standard deviation that goes along with these types of computations. And we had a formula for that in class. It's the square root of p times 1 minus p over n. And for us, the n is 172, and the p is the 32%. So I guess I ended up using 0.3198 because I figured that 55 was the right number, but let's just say it was 32%. So I'm going to plug in the proportion from our sample, which is 32%. And I did this earlier. I don't know if this is going to show you the other Word document when I flip over, but I did this earlier and I got 0.0356. So 0.0356. And then that's a standard deviation. Now, 99% confidence interval is sort of the middle chunk of the bell cut off with sort of two tails on the outside sharing the 1% that's left over. And during the normal distribution chapter, or maybe the confidence interval chapter, we talked about how those cutoff points are 2.576 standard deviations from the mean. So our margin of error is equal to 2.576 times the amount we have for our standard deviation. And this comes out to 916. Okay, so that's another way to get it. So the reason this is 916 and this one's 986 is because this one, just by using this 25676, it's automatically doing, this is a normal approximation method. That's where this 2576 came from, is from the normal distribution. So this is the number that you get when you use the normal distribution. The 986, that's using the more accurate method of using the binomial distribution, the exact method in Minitab. Okay, so either is fine. This one's just a little bit better. They're all just approximations anyway. Okay, so yeah, so that's enough for this question.